All right, so this is your solving exponential and logarithmic equations. There are several different types of equations we could encounter, so it's real important to kind of understand the characteristics given so you know what method to use. So the first type we're going to look at is solving when we can get the bases the same. I call this the GTBTS method. And this method uses this idea here. If we can write both the left and right sides of our equation using the same base, b, 3, 2, etc., then I know that the two exponents, that is not a highlighter, nor do I like yellow, the two exponents, x and y, would have to be equal. So if the bases are the same, the exponents are also the same. However, this method will only work if they have a base in common. If you have a number like a 3 and a 7, 3 and 7 as bases have nothing in common, so that this way would be out. All right, so first one here, we have base number 1, which is 3. And then the number on the other side is a 9. So what we're trying to see is, do they have a base in common? Can I write them both in terms of the same base? And the answer is yes, they can both be written using a base of 3. So the left side is already in terms of that, so we're going to leave it alone. 3 raised to the 2x power. The right side I want to rewrite using a base of 3. So we're thinking 3 to what power is 9? Well, it's 2. So now the left and right sides have both been written in terms of a base of 3. So that means we can ignore the bases since they are the same on both sides and just pull the exponents. So that means 2x has to be equal to 2. Then we continue solving for x. So we would, in this case, divide by 2 on both sides. And 2 divided by itself is 1. So the answer is 1. Second example. All right, B, we're given 2 to the power of x equals 64. So we want to think base in common. So 2 is very, very simplified. There's really no other way to write it without getting fancy, and we'd rather not get fancy. So we are looking at, let's see, what could I use pink? So we're thinking 64. So we're thinking, is 64 a power of 2? And it is. So left side, 2 to the x. Right side, 64. If you're unsure of your powers of 64, you can try 2 to the third is 8, 2 to the 4, 16, 5, 32. 2 to the 6th is 64. So now that both the left and right sides are written in terms of the same base of 2, we can ignore those bases and set the exponents equal. Well, that gives us x equals 6. So since x is already by itself, we're finished. All right, C. All right, this time, trying to figure out a common basis. Sometimes these are a little more tricky, especially when we start bringing fractions in. So my suggestion is, don't try to turn bases into fractions. Try to undo the fraction. So I've got a choice of a 3 and a 1 over 27. 3 is nice and simple. So we are going to rewrite both sides using the base 3. So we might need to do this in a couple of steps. So left side is as simplified as it can go. 3 raised to the 4x minus 1. 1 over 27. I'm going to ignore the 1 for a minute, and I just want to focus in on the 27. 27 is 3 to the third. So I've got the 27 in terms of a 3. Now I need to get it out of the denominator. In order to get it out of the denominator, we need this exponential property. So there's 2 ways to write this exponent property. A to the n is this equivalent to 1 over a to the negative n. Or vice versa, 1 over, I'm going to change letters just so it doesn't get confusing. B to the n is equivalent to b to the negative n. So what that means is, if we change the sign of the exponent, we can move the exponential term from a denominator up or from a normal number down to the denominator. So I can take this entire chunk 3 to the third and move it into the numerator, so that, in other words, undo the fraction, as long as I make its exponent negative. So that has no effect on the 3 raised to the 4x minus 1, but that, instead of giving us 1 over 3 to the third, is going to give us 3 to the negative 3. So we just negate that exponent. So now the left and rights are both in terms of a base 3. So we can drop them and ignore them and set 4x minus 1 equal to negative 3. And then we continue solving for x. So we're going to add 1, which gives us 4x equals negative 2. And then we're going to divide by 4 on both sides. So we get x equals negative 2 over 4 reduces to negative 1/2. So anytime you're doing a fraction, get the denominator in the same base first and then clear that denominator using a negative. All right, second method we're going to go over is still exponential equations, but this is going to be, well, what if you cannot get the same base? So that means like you're dealing with a 5 and a 7 that have no base in common, a 2 and a 3, etc. So there's your steps right there if you need to reference them. So we're going to go through these one at a time. So you got to know which method to use and why. So with this one, 3 and 5 have no powers in common, so I do not have that option there. So the idea here is I need to isolate the base with the variable in the exponent. So like if there was a number added or subtracted back here or a number multiplied on the front, I got to move it to the other side. Since it's already isolated, we're going to take a log of both sides. Technically, it does not matter what log you take. I am going to take a natural log every single time. That's just the one I like. And I also only have to write down ln instead of log. So natural log of the left side. If I take the natural log of the left side, I have to take the natural log of the right side. Log properties. So we need a log property here. So I'm going to come over to the side and write it down. If I have the natural log of a raised to the b, remember, we are allowed to take that exponent and move it to the front, and it becomes multiplication. So that's the property we're going to use right here, is that x, I am now allowed to take that x out to the front and change it to multiplication, so that we now have x times the natural log of 3 equals the natural log of 5. All right, the natural log of 3 is a number. It's not a pretty number, but it is just a number. So we treat it like any other number. If we're trying to get x by itself, we need to divide by that number. So x is now isolated. I have x equals the natural log of 5 divided by the natural log of 3. Most of the time, the directions here are going to ask you to give your answer to the nearest third decimal place, fourth decimal place. This would be the exact answer, but let's suppose it says round to 3 decimal places. So at this point, we're going to go to our calculator and we're going to type in the natural log of 5 divided by the natural log of 3. So the answer, I'm going to round to 3 decimal places, is going to be 1.46, and then it's 49. So that would bump to a 5. So just make sure you read carefully so that you round to the appropriate digits as needed. All right, second one. All right, this time we are given the 9 times e raised to the 2x equals 30. So if I look at this, I got a lot of numbers going on. E can't be written in terms of any other number besides itself, e. So first thing here, locate your variable exponent and the base associated with it. The base associated with that x is only the e. It does not include the 9. The 9 is in front. So we have to get that completely by itself. So first thing we need to do is we need to divide the 9 off. That is going to give us, zoom in a little bit, e raised to the 2x equals 30 over 9. It doesn't divide nicely, but it does reduce some. So we want to put it in its lowest form. We can take a 3 out of each, so that's 10/3. So now that it's isolated, you can technically take whatever log you want on both sides. I told you every single time I'm going to take a natural log because that's the one I like. If you want to take a common log, the log, you can do that as well. So I'm going to take the natural log of the entire left and the natural log of the entire right. All right, log properties. So we can use that same idea as we used on the last one, that we can bump that exponent to the front. But here you actually have a better property. If I have the natural log of e to the a, remember the base of an ln is e. What's in the log is also e, so the answer is just the exponent. So there's no reason to move that 2x to the front and then try to clear that ln of e. ln of e is just 1, so this is just 2x. If the base of the log and what you're taking the log of match, the answer is the exponent. On the other side, this is a terrible number, so we're going to not touch it yet. So to get x by itself, we either divide by 2 or we multiply by a half. Totally up to you which way you want to write it. I'm going to multiply by the reciprocal because it does look better to me. But if you want to do a blanket division bar by 2, same thing. So I've got x equals 1/2 times the natural log of 10 over 3. Again, usually it's going to say round to the nearest tens, hundreds. It's going to tell you to round somewhere. So we're going to assume, I like to round to 3 decimal places most of the time. So we're going to suppose the directions say round to 3 decimal places. So that's what we're going to do. So now we're going into our calculator. And very carefully, we are calculating the natural log of 10 divided by 3, or 10/3. And we are taking that and multiplying it by 1/2. And so that is going to give us x equals, it is 601 and then 9. So that 9 is going to bump the 1 to a 2. So just read carefully to make sure you round correctly. You don't want to get it wrong because you typed in 3 and the direction said 4. So just read carefully. All right, C. So we got a lot of numbers going on here. All right, so first locate your x. It is in the exponent associated with the 7. So that means I need everything else on the other side. That -1, careful, is up in the exponent. So don't try to move it to the other side. All we can do right now is move the 2. So we're going to divide by 2. So we're going to get 7 raised to the negative 0.3x minus 1 equals, if we take 0.2 and divide it by 2, it is 0.1. So because it is a nice pretty decimal, if you want to use the decimal form here, that's fine. If you'd rather change it to fraction form, you can. I'm going to use decimal form since the original equation is using decimals already. So now we have that base completely isolated. So I'm going to take the natural log of both sides. So ln of the entire left and ln of the entire right. Remember, once we take a natural log, so ln is 7, we can't do anything with it, but that does allow us to take the exponent here and move it to the front with multiplication. Just be careful when you move it to the front. Move it to the front as a whole, which means you need to have parentheses around it. We get here. All right, at this point, I would recommend, there's no reason to distribute the natural log of 7 because it is a very, very ugly number. So instead, let's just go ahead and divide it off. I don't want to try to distribute an ugly number. I'd rather just move it to the other side. So this answer is going to get a little bit complicated in the way it's written. We'll just need to keep it written that way and then just at the end, type it all into our calculator. So now we have negative 0.3x minus 1 equals whatever this is going to come out to. So just leave it like this. We don't want to do any rounding until the end. And look at that, I'm out of room. So we're going to like scoochy. Oops, took my 2 with it. I'm going to scooch this way just a little bit. And then I'm going to scooch this that way just a little bit more. I'm going to put a line in here to separate it. And then I'm going to continue working. I'm going to go up here. That's my little terrible arrow. So just kind of, whoops. All right, so I'm going to copy that down. We've got the negative 0.3 x minus 1 equals, and then we're going to squeeze this ln 0.1 over ln 7 in. So it's in there, barely, but it's in there. All right, so next step would be we've got to move the 1 over because our goal is to get x by itself. So I'm going to add 1. Now that 1 is just going to need to get added at the back. So we've got our 0.3x equals this ln of 0.1 over the ln of 7 and then plus 1. So just float it at the back. Last thing is either to divide or multiply by the reciprocal here. Again, it's totally up to you. A lot of y'all do like your division, so I'll go ahead and divide this one just so you have an example of both. So we're going to divide it off. You just need to make sure you're careful how you write this thing. So that's going to give us our x by itself. So we've got a lot going on here. So I'm going to put my main division bar with that 0.3 in the bottom. And then the numerator is going to be the ln of 0.1 over the ln of 7 plus 1. So that's kind of a little complicated looking. And then, again, read carefully for how many decimal places you need to round to. So now we're going to go to our calculator and type this in. This is where you really want to make sure you're using that fraction template here, because you got fractions upon fractions. All right, so type in, I'm going to get my fraction template, and then I'm going to create another fraction template in my numerator. Type in the natural log of 0.1. Go down to that little baby denominator and type in the natural log of 7. Get out of that little baby fraction, then type in the plus 1. Onto the big denominator, type in the 0.3. So the way you type it in your calculator, it should look exactly the way it's written in this set of notes right here. And then it's going to spit out negative 0. And we get 6109. That 0, or that 9 is going to bump the 0 to a 1. So negative 0.611. So I'll just try to zoom out where you can see. There's that whole problem. You need to pause it there. And then we'll zoom so you can see all three, maybe. They're going to be tiny. Maybe. There we go. They're little. All right, so those are your exponent equations. Next thing we're going to look at is logarithmic equations. So there's several types of logarithmic equations you could encounter as well. Biggest thing you need to understand with a log, it's very, very important. Remember, the log has a restricted domain, so we need to check every answer to make sure it actually works. Logs are known for giving extraneous solutions sometimes, and an extraneous solution is like a fake solution. It doesn't actually work, so we have to check the answers. All right, first idea with the log is the same idea as an exponent. If I have logs on both sides, so like the log of some base and then the log of that same base on the other side, we can simply just ignore the logs and take the numbers inside the log and set them equal to each other. All right, so first one, we're given the log of 4x equals the log of 3x plus 1. So the left side has a log containing all of the, okay, that's not what I drew, but whatever, containing the 4 and the x. The right side has a log containing the 3x plus 1. So since both sides are entirely encased in a log base 10, we can just drop the logs. So that means 4x has to be equal to 3x plus 1. And then we can subtract the 3x from both sides. And we're going to get x equals 1. Done. However, this is a log equation. Check it. So what that means is go plug it in everywhere you have a log and make sure the number is going to be positive. So I'm coming up here and I'm plugging in 1. 4 times 1 is positive 4. So we're good. I go to the other log. I plug in 1. 3 times 1 is 3. 3 plus 1 is positive 4 as well. We're good. If you have to get a positive for this to actually be an answer. All right. B. We are given log base 2 of 2x plus log base 2 of 3 equals log base 2 of 2x plus 9. So we have logs on both sides, so we're going to use the exact same idea we just used. However, that idea does not work unless it is a single log on the left and a single log on the right. So in order to use it, we got to get to a single log. So this is going to use that condensing property. Write it as a single log. Plus between two logs translates to multiply inside. So I am going to write 1 log base 2. I'm going to open a set of parentheses and I'm going to take the 2 insides. So inside number 1 is 2x. We are going to multiply, and then we're going to go get inside number 2, which is, that's not the color I want to use, 3. And we're going to multiply by 3. That was a large set of parentheses. I didn't need it to be that big. And the other side, we're just dropping down. All right, from here, I have the left side down to a single log. I have the right side as a single log, so we're just going to drop the logs and continue. So 2x times 3 equals 2x plus 9. 2x times 3 is 6x. Let's move our 2x over. 6 minus 2 is 4x. And then we divide by 4. Divide by 4. 9 over 4 does not reduce. Most of the time, this type of equation, it might leave it as the fraction 9 over 4 since it is a nice, pretty fraction. If it says give your answer rounded to the whatever decimal, type it in. It is 2.25. So again, just read carefully on the questions to make sure you enter the answer in the right format. So I'll box both of them this time, since we did have a nice, pretty fraction. All right. Last type of equation is what we're going to do when we do not have logs on both sides of our equation. So here's your steps if you want to reference those. But again, the most important is going to be remembering to check those answers. Oh, and look at that. I didn't remember to check the answers on the last one. So let's go back and check because, oops. So 9 over 4. So again, we're going to plug back in here. 9 over 4 is a positive number. If I take a positive number and multiply by 2, it's going to stay positive. So we know we're okay there. The 3 doesn't have an x in there, so we know that one's going to be okay. There's nowhere to check it. And then over here, this last one, if I take a positive number, plug in for x, so if we plug in 9 over 4, we multiply by a positive 2, it's still positive. And then we add 9. Adding makes it more positive, so we're good. Everything's going to come out as a positive number. So yeah, don't forget to check like I just did. Anyways, back to your log steps. I'm going to underline it this time. Check your answer. I forgot. All right, so example 1. So solving this type. So this time we don't have logs on both sides, so we can't take the insides out and set them equal because there is a single log. So it's going to work similar to those second type of exponential equations. We need to get the log and everything in the log completely by itself. So if we look at this problem here, the 4x is contained inside of the log and it's already on a side by itself. So since it's on a side by itself, we can go straight to exponential form. So what we're going to do is we're going to convert it to exponential form. The base of this log is not written in. Remember, default base is a 10. So if you want to put a 10 there, you can put a 10 there. And then we're going change to exponent form. So recall, we'll squeeze that in up here real quick. If I have log base b of a set equal to c, and I am trying to change over to exponential form, remember you start at the base b and make this counterclockwise loop. So that is going to become b raised to the power of c equals a. So that's the property we're going to use to solve these types of equations. So I'm going to start at my 10. Counterclockwise loop. So I'm going to get 10 raised to the power of 2 equals 4x. And now I'm out of the log. 10 to the second power is 100, 10 squared. And then we divide both sides by 4. So we get x equals 100 divided by 4 is 25. So no reason to worry about fraction or decimal. And then if we go check, remember, plug it back in for x inside the log. 4 times 25 is positive, so we don't have to worry about anything there. This isn't a valid answer. All right, b. So we are given 2 times the log of x minus 5 plus 1 equals 5. So locate your log and what is inside of your log. So this time the stuff on the inside is just the x minus 5. Whoops, I drew a rectangle. Please draw a rectangle. There we go. So before we can go to exponential form here, we actually have to move stuff first. You cannot go to exponential form until it's isolated. So we're going to subtract 1 from both sides. 2 times the log of x minus 5 equals 4. That 2 is being multiplied, so we are going to divide it off. So I'm going to divide both sides by 2. So we have log x minus 5 equals 4 divided by 2 is 2. Now our log is completely isolated. So we can go to exponential form. Notice the base on this log is also not written in. Remember, when it's not there, it defaults to a base 10. Write a 10 in there if it helps. And we go around. So 10 to the second power equals the inside, which is x minus 5. So 10 to the second power equals x minus 5. All right, 10 squared, that's 100. Then x is not by itself, so now we need to isolate it. So we're going to add 5. And we get 100 plus 5 is 105 equals x. We have our answer. Go check it. So you're going back up to the original problem and plugging it inside of the log, just on the inside. So we're going to go plug in 105 here. So if I plug in 105 for x and then subtract 5, it's still positive. So that means we're okay to keep it. It must be positive when you plug it in. If it's not, throw it out. All right, C. All right, C is a little bit different. We have more than one log, but they are not on opposite sides of the equal sign. So if they are not on the opposite sides of the equal sign, we can't set the insides equal. So in this case, we need to condense to a single log. So if you have more than one log on the same side, condense to a single log. So this one's got addition between. Addition, remember, translates to multiplication inside. So I am going to write log. Also notice the base is 2, so don't forget your base 2. And then I'm going to open a giant set of parentheses. And we want to multiply the two insides together. So one of the insides was x minus 1 times, and then the other inside is x plus 1. All right. So this log is now completely isolated. There's nothing outside of it, and it's also down to 1, so we can go to exponential form. Start at the base 2, counterclockwise loop around. So we're going to get 2 raised to the third power equals the inside, which is x minus 1 times x plus 1. Oops. All right, 2 to the third, not 6. Be careful, it's an exponent. That's 8. On the right side, we need to go through FOIL. So first outside, inside, last. So first is x times x, x squared. Outside, positive 1 times x, positive x. Inside, negative 1 times x, so negative x. Last, negative times positive, negative 1. X minus itself is 0, so we have 8 equals x squared minus 1. So at this point, if you still have the x squared and there is an x term, you're going to have to move the 8 over to the right and factor it. Since we only have an x squared, I just want to use a square root property. All right, so I'm going to move the 1 to the right, or to the left instead. So 9 is equal to x squared. Remember to undo a square root both sides. So I'm going to square root the left and right. However, don't lose that plus or minus. So we're going to get x equals positive or negative. The square root of 9 is 3. So that means x equals 3 and x equals negative 3. We have 2 answers. Check all answers. So let's go check 3. All right, so way back up here. If I go plug in 3, I'm plugging into the original equation and both logs. So if I plug in 3 here, 3 minus 1 is positive. I'm good. If I plug in 3 here, 3 plus 1 is positive. I'm good. So this is an answer. Now let's go check negative 3. So if I plug in negative 3 here, negative 3 minus 1 is a negative number. We are not allowed to have negatives or 0 inside of a log. So that is an issue. It is not one of your answers. So x cannot be that negative 3. A lot of times this is called an extraneous solution. It is not a solution. It's like a fake solution. It does not work in the end. So be very, very careful of that. Always check your answers, because every now and then you're going to get 2 and 1 works and 1 doesn't. All right, so there are those. All right. Yep, the rest are you try it, so feel free to go to the completed notes, try the rest of them, and check them when finished.